Hey math fans, we're on section 2.6.3. Let's get started. In this section, we're going to be comparing linear functions to exponential functions. So let's take a look at example 1. Which function increases faster? F of x equals 4x minus 5 or g of x equals 4 to the x minus 5. Justify your answer with a graph. For every single one of these problems, you're going to hear me say time and time again, please make a table. A table of values will tell you what is happening in both of the functions to do the best comparison possible. Notice that f of x is the linear function. It's 4x to the 1 power minus 5. It is going up at a very steady rate, increasing by 4 as x is increasing by 1. The exponential function, on the other hand, is doing something very different. It's barely increasing, and then all of a sudden, it rapidly increases. Using the table of values, you can graph each of these functions and take a look at how they behave. The exponential function has an asymptote at y equals negative 5, and that's why it's starting off so slowly, but then rapidly takes off. And then if you notice, the other function is just steadily increasing by 4 every time x increases by 1. To summarize and compare the rate of change for each function, the graph of f of x equals 4x minus 5 appears to be steeper than the graph of g of x equals 4 to the x minus 5 until the point 1 comma negative 1. As you can see, right there is when g of x starts to increase more rapidly than f of x. Example 2, at approximately what point does the value of f of x exceed the value of g of x if f of x is equal to 2 times 4 raised to the x over 20 power, and g of x is equal to 0.5x? Justify your answer with a graph. Again, first things first, make a table. Take the time. Substitute in numbers like 0, 2, 4, 6. When graphed together, these two functions are doing something interesting. F of x actually starts at a higher position, or in other words, the y values are actually greater than that of g of x until about this point. The y values of g of x are greater than the y values for f of x until about this point. And it's at that point that f of x really starts rapidly increasing. So we can identify the approximate point where f of x is greater than g of x. It can be seen by the graph that both functions are equal when x is equal to approximately 28. Right when x is equal to 28 is where f of x starts to become greater than g of x. Example 3, Lena has been offered a job with 2 salary options. We have f of x equals 500 times x plus 31,000. And then you have g of x equals 29,000 times 1.04 raised to the x power. Again, this is another which salary option should she choose? Obviously, you want to make the most money as soon as possible. However, maybe one is better in the long run. We're going to have to analyze this. As always, make tables for both of the functions, and you can see what's happening. F of x definitely starts out higher or greater than g of x. So if she takes option f of x, that's got a better base starting salary, but is it best in the long run? As you can see with the graph, there is a point where the exponential function will overtake the linear function, even though it started off at a higher position, somewhere around here. It can be seen from the graph that after 3 years, g of x is greater than f of x. And if Lena is hoping to keep this position for at least 5 years, it's in her best interest to choose salary option modeled by the 29,000 times 1.04 raised to the x power. And that's going to do it for this section. We'll see you in class.